Good evening, boys. Today we will be doing a short lesson on graphs. You know, subjects like physics, maths, economics, they study the relationship between two things or between one and more things. And when I say relationship, we are talking about a mathematical relationship, which could be, say, of an algebraic nature. It could be logarithmic, trigonometric, or something more complicated. So these relationships can also be plotted in the form of a graph. Graphs supply visual information about these relationships. So we will be learning how to plot simple graphs and how we can glean some information from these graphs, such as the slope and the area. So physics is the study of relationship between two things or between one and more things. So usually if you know something about it, then that relationship can be represented in the form of a mathematical equation. So say in a general way that equation can be written like this, which we say y is a function of x. So y could be displacement, x could be time, y could be velocity, x could be time, anything. Now let's say in a particular relation between x and y, this y is a function of x. Say it takes a simple form of this equation, y equal to 2x. We are just learning how to plot a graph. So if x is 0, then y is 2. If x is 1, then y is, sorry, when x is 0, y is 0. When x is 1, y is 2. When x is 2, y is 4. So let's say we take these points. So we've got a table with x and y. So x has got values 0, 1 and 2, and the corresponding values of y are 0, 2 and 4. Now a graph will have two axes. So this is called the x-axis and this is called the y-axis. And in this case, look at the numbers I need to plot on my x-axis. So it starts from 0, which is here, then 1, 2. Because these intervals are equal intervals, make sure that when you draw a graph on an exercise book, to make these distances exactly the same. Most of the times graphs are not accurate because you make mistakes, careless mistake. So if this is 2 centimeters, then this should also be 2 centimeters. Of course, when you use a graph paper, you are counting the number of squares, so it becomes even more accurate. Now, in this case, we plot this on the y-axis, and if you see here, the kind of numbers that are there for the y-axis are not very different from the numbers in the x-axis. So I could start my graph here on the y-axis also from 0. So I can write 0 and 0. This first 0 stands for the 0 for this axis, and the second 0 stands for the 0 for this axis. So this is 1, 2, 3, 4, like that. Say if you had another set of data in which when x was 0, y was 10, when x was 1, maybe y was 20. In that case, your graph need not necessarily start from 0 for the y-axis. You could make it start from 10, 20, like that, in which case it would be 0 and 20. So you will learn those things later on as you get enough practice. So if you see, these are the points. So the first point is when x is 0, y is 0. So this is the first point to be plotted. When x is 1, then y is 2. So you got it here. And when x is 2, y is 4. So these are the points, and then we can join these points. Of course, here it is a straight line because a graph of this nature will actually give you a straight line passing through the origin. But in some other cases, the graph may take up different forms, like it could be in the shape of a curve. Sometimes it would just be a scattered, points on the graph. So that you will learn as and when those special type of relationships you study in physics, either in class 9, 10 or the higher classes. But the other thing to just remember is that now we are just plotting numbers on x and y. But in physics, it's not about numbers. Numbers means certain things. So you need to know what you are plotting on the x-axis, and then you need to write down along with the unit. Like in the case of a motion time graph, all the graphs will have time on the x-axis and time would be measured in seconds. And on the y-axis, if you have displacement, then you write displacement, and in the bracket you write down the unit in which the displacement is being measured. So that is something that you need to be careful. And now in the next section, we are going to learn more about the slope of a graph. Now let us learn something about the slope of a graph, how to calculate the slope and what it signifies. So imagine this is an inclined A to B. When you go from A to B, as you will notice, you are covering a horizontal distance which we call delta x. But also as you go from A to B, you are covering a vertical division distance which we call delta y. So in going along this slope from A to B, you have moved a certain horizontal distance, but you have also gained a certain vertical height. So the slope of this particular graph is defined as the ratio between the vertical height to the horizontal distance. So just try to understand something, that when you go from A to B, there are two types of changes taking place. One is the change that is taking place in the horizontal direction, and also there is another change which is taking place in the vertical direction. So slope, you can say, is the ratio of the change in y because of a certain change in x. So once again, slope is delta y by delta x. So from the way that we have defined our slope, let's say this is x and this is y, and let's say a graph takes up the form like this. So in this case, I told you that the slope of this graph, say OP, is a certain ratio of the vertical distance that is covered when a certain horizontal distance is covered in the graph. So this slope is delta y by delta x. Now, if you just look at this one, then you will get some idea about the significance of slope when it comes to a real graph. Like say for example, I've got a graph in which I have got here say distance, and here I've got time. Now no matter what kind of shape the graph takes, so let's take a simple shape like this. So now we have got the slope of this graph. So here this is a distance time graph. So in this case the slope is change in y by change in x. But remember, the change in y is actually the change in distance, and the change in x is the change in time. But we know what is the ratio between the change in distance to the change in time is. This is speed, isn't it? So what do we get? When you have a distance time graph, the slope will give you the speed of the motion that the distance time graph represents. Similarly, if you had displacement, then you would get slope is the displacement upon time, so that would give you the velocity. Or say if you had velocity and time, then in that case the slope would give you change in velocity upon change in time, which is acceleration. So just to repeat that, the slope of any graph is the change in y, is the ratio of the change in y to correspond to a change in x. And in your syllabus, if you have say a distance time graph, then the slope of a distance time graph will be change in distance upon change in time, which is the speed. And the slope of a velocity time graph would give you the acceleration. This is just a basic idea. Now we'll just like to develop these points further. Now let's learn a little more about slopes. So as I told you that we have just been drawing these graphs like this one. But remember that this straight line is only when there's a certain type of relationship that exists between x and y. And if you recall the first graph that we plotted, this is usually the case when you have a relationship which is something like y equal to kx. If the relationship is something else, then the shape of the graph would be different. Now, what is the significance of a straight line graph is that if you look at this one, so say I want to calculate the slope between the intervals x1 and x2. So corresponding to x1 we have got y1, and corresponding to x2 we have y2. So if you see here this one, so which I call AB, so AB will have a slope which is this one. So from here to here is y2, from here to here is y1. So this is y2 minus y1, and from here to here is x2, and from here to here is x1. So this interval is x2 minus x1. So the slope will be y2 minus y1 upon x2 minus x1. Now you can try it at home. if you take the interval, say another one, so say from P to Q, then just as what I have done, then you will be able to get something like this. So it will be this divided by this. But you will find that no matter what interval you take, the slope is going to be the same, which means that when you have a straight line graph like this graph has got a constant slope. So this is y, this is x. So this graph will have a slope that is constant. But mind you, slope was the change in y upon change in x. Therefore, a graph which gives a constant slope means that the change in y with respect to change in x is a constant. So say if this was displacement and this was time, and then you have a graph like this, then slope is constant, means change in distance upon change in time is constant. But we know that the change in distance by change in time is actually the velocity, so or rather the speed. So in this case, a straight line graph in which we have displacement in the y-axis and time in the x-axis actually represents constant speed. So it represents motion with constant speed. Now in the next instance, we will try to do a type of graph in which the relationship between d and t is slightly more complicated. That is, it's not a straight line but something else.